In this video, we are going to talk about container use cases and explain why do we prefer containers over something like virtual machines. Containers can help us solve a lot of common problems that we encounter as administrators or DevOps engineers or developers. These problems such as dev-prod parity and the need to migrate servers. Containers also help us build microservice-based architectures. They can help us create elastic and self-healing architectures, and they just fit with the CI/CD pipelines. Well, let's get started by looking at how containers can help us solve the "it worked on my computer" problem. And this is because when you are deploying using containers, the container running in your production machine is going to be the same container that's running on the developer machine. So if these are based on the same container image, then we can expect the result regardless of the hardware and the operating system used on both production and developer machine. Also, it doesn't matter what libraries they actually have installed on their underlying base operating system, because in the container image we have our application and the prerequisites needed to make that application work properly. So everything is going to be accurate, and again, since we are using the same container image in the dev and the prod environment, then there will not be any disparity. And likewise, this same concept is practical when we are working with migrations. So if we have a containerized infrastructure and we need to move that infrastructure, then all we need to do is lift and shift our containers. And then we can move these containers to new hosts or to new clouds without actually having to change the image or think about what will happen to the image if we take that image and deploy it on Ubuntu machine when it used to be running on real machine. Because again, it's all packaged in the container image, and what's going on in the deployed container is not going to change regardless of the underlying operating system. Which means we are also able to redeploy things quicker if we need to migrate. And on the opposite, when we are migrating from a virtual machine to another virtual machine, we have to wait for that full provisioning and configuration management to run. But instead all of that, the container image is already pre-packaged. It just takes that container and it's going to deploy that container without having to wait for a full OS to install and for any provisioning to happen. Of course, containers don't just make deploying things quicker and easier. They can also change how we actually architect our application as a whole. So traditionally, when we built an application, it would tend to be a monolith, which means everything in that application is stored together. So you will have the user interface, and then you will have all of the services packaged in one container. But what if only one of those services, like the database, requires a lot of resources and our database is already packaged with the application as a whole? In this case, when we need to scale up, we are going to have to scale another version of that application. So we are going to have another full application container that's going to contain another copy of the UI and another copy of all of the services that are packaged with it, not just the database. But if you move away from monolithic architecture and instead store each service and UI component in its own container, then you will be able to scale each component individually. So if it's the database and nothing else that really requires more resources, then you are able to add more database containers without having to duplicate services that are working just fine. Using that approach will really save a lot of resources in the long run, because again, you are not making duplicates of services that don't need to be expanded. when it's only one component of the application that's really being problematic or needs additional resources. Now moving on, while containers do isolate, containers don't work in isolation. So what does this mean? This means that most often we are using containers within a DevOps context, which means we are using them with other DevOps tools such as orchestration and other monitoring tools that will really help us to manage our deployment. And especially when we integrate the containers with the orchestration and monitoring tools, we can create an elastic architecture. So what does this mean? This means we are going to monitor our containers for CPU, memory, data usage, and other metrics. And if we are using too much CPU, or if we are using too much memory, or if our read-write times for our data is getting too slow, then we can scale out. So basically it just means that our monitoring system is going to watch for certain metrics, and if let's say our CPU hits 80% and that metric we denote it as problem, then our monitoring component will notice that, and then it's automatically going to tell the orchestration system to scale out and add another containers so that CPU load can then be distributed among them. And likewise, the orchestration tool can be configured to scale in. So if our CPU usage drops down to 10% on our two containers, so the orchestration system will see that and then remove the additional container to save resources, and then move everyone back on that single 10% CPU container that can handle all the traffic. Likewise, we can also configure the same kind of setup to enable a self-healing architecture. So it's the same concept. You are going to be monitoring your container for when services go offline or when certain errors are received, depending on what your application does. And then once that happens, it's automatically going to terminate that container, so there will not be any need to troubleshoot the container itself. It's just going to get removed, and then it's going to get replaced with another healthy container. Keep in mind that, of course, if there is something wrong with the underlying container image, you are still going to have to go ahead and troubleshoot that image. Then finally, we can leverage containers with the CI/CD, or continuous integration and continuous delivery pipeline as a whole, just because the deployment and the creation of container images and containers in general really fits with the whole CI/CD pipeline concept. And it's the idea of being able to push a change to your application or your code to a centralized repository like GitHub, then automatically have that change detected via your CI/CD pipeline tool such as Jenkins. So something like Jenkins will notice when you make a push to GitHub for your application, and then it can automatically start a build that's going to create a new Docker image based on that change. And if you have it set up to do testing, then it can test that image to make sure it works properly. And then if it passes all of these tests, it can automatically go ahead, take that new version of your application and deploy it to your environment, and this means it will be removing any containers that contain the old version and replacing them with the new ones. So to wrap up, we know that containers fit into a number of workloads and really have a number of use cases and solve a number of common problems we may encounter as engineers, administrators, and developers. And these include solving the dev-prod parity problem, migrating infrastructure, and working with microservice-based architectures, as well as helping us make sure our architectures and our infrastructures always up and running by making them elastic and self-healing. And then of course we know that containers can be used with CI/CD pipeline in general. So from here we are going to start learning these concepts and use cases by getting hands-on with Docker, starting by installing Docker in the next lesson. So I'll see you there.